Good day, class. Today we are going to start the unit on rational functions. This will be another short unit. We'll just take a few days of graphing them, and then you will have your assessment on Friday as usual. All right, so to graph rational functions, I think that it's useful to have a set of steps. All right, so first we're going to want to find our x-intercepts. And to find your x-intercept, all you do is set the numerator equal to 0 and solve. Right, next we will want to find our y-intercept. Right, in order to find your y-intercept, you simply plug 0 in for x. Right, we will also need vertical asymptotes, which we talked about last unit. Right, to find your vertical asymptotes, you set the denominator equal to 0 and solve. Right, horizontal asymptotes, which we also talked about last unit. Right, that's where we compare the degrees of the numerator and denominator. All right, we'll also talk about slant asymptotes a little bit later, but we'll get to that another day. All right, now we're also, we can also check for what's called holes. All right, you will have a hole or multiple holes in a graph. If a factor in the numerator and denominator cancel. All right, your hole will have an x and a y coordinate. All right, to find the x, you set the canceled factor equal to 0 and solve. To get the y coordinate, you simply plug the x that you just found into what is left. All right, and then finally we'll need some extra points. All right, where you just pick where you simply pick x coordinates and plug them in and you get y coordinates. However, we do want to pick our extra points strategically. All right, choose x values at the edge of your graph. And on either side of all vertical asymptotes. All right, so that's all of the things that we are going to want to do for rational functions, all right, to graph rational functions. find all of these. All right, so let's look at an example. All right, so here's our rational function. Let's kind of go through our steps. So first, we'll find our x-intercept. Remember, we set the numerator equal to 0 and solve. So in this case, it's very easy. 3 is my x-intercept. To find our y-intercept, we plug 0 in for x, and in this case, we will get negative 3 over 5. Very easy there. All right, to get vertical asymptotes, we can set the denominator equal to 0 and solve. So x equals negative 5. Horizontal asymptotes. All right, we compared the degrees of the numerator and denominator. They're both 1. All right, so we take the ratio of the leading coefficients. So in this case, just y is equal to 1. All right, there's going to be no holes because there's nothing that canceled in the top and in the bottom. All right, so now we're just going to want to get some extra points. All right, remember we want to pick our edges. So whatever graph you're using, in this case, my graph goes from negative 10 to 10. So I will want to use negative 10 and 10. And then we want to pick x coordinates on either side of our vertical asymptote. So if my vertical asymptote here is negative 5, then I would want to pick negative 6 and negative 4. All right, now I just plug these in to my function to get my y coordinates. When I plug in negative 10, we will get negative 13 over negative 5. So that is 13 fifths. Plug in negative 6, we get negative 9 over negative 1, which is just 9. Plug in negative 4, you get negative 7 over 1, so negative 7. All right, and plug in 10, you get 7 over 15. All right, I like to put asymptotes as dashed lines. So I will have one at negative 5, and I will have a horizontal asymptote at 1. All right, now we'll go ahead and put all of our other information on here. So we have an x-intercept at 3. All right, we have a y-intercept at negative 3 fifths. We have the point negative 10, 13 fifths. So that's 2.6 roughly. All right, we have negative 6, 9. All right, we have negative 4, negative 1. Well, negative 4 should be negative 7. Sorry about that. All right, and then 10 and 7/15, which is right around a half. All right, so now between our asymptotes and our points, it's fairly obvious what's going on here. It's obviously a little bit off, but You get the point. Obviously, this should be nice and rounded here. It's hard to do it on this pad that I'm working on. A little better. And that's it. That's all we have to do. All right, so you may want to pause the video here and try one on your own. All right, and then unpause it to watch me work it out and see if you did it correctly. All right, so first again, we'll find our x-intercept. We set the top equal to 0 and solve. So we will get x is equal to -6. Our y-intercept, plug 0 in for x, so we get 6 over -6, which is -1. Vertical asymptotes, we set the denominator equal to 0 and solve, so x is equal to 6. Horizontal asymptote, we compare the degrees of the numerator and denominator. They're both 1, so we take the ratio of the leading coefficients, which 1 over 1 is 1. All right, nothing canceled, top and bottom, so there are no holes. All right, now we just want some extra points here. Again, my edge points for this graph are -10 and 10. My vertical asymptote is 6, so on both sides of 6, we have 5 and 7. We go ahead and plug these in. Here we will get -4 over -16, so that's just positive 1/4. Here we will get 11 over -1, so -11. 7, we will get 13 over 1, which is 13. And even though these aren't necessarily on our graph, they're still very useful to us. When we plug in 10, we get 16 over 4, which is 4. All right, so again, we can put our asymptotes on here. So we have x equals 6 and y equals 1. All right, we have an x-intercept at -6, a y-intercept at -1. We have the point -10, 1/4, 5, -11. So that would be down here somewhere. We have 7, 13, which is way up here somewhere. And we have 10, 4. Right, so again, this is going to be enough to let us know what's going on. And voila, we are done. All right, we'll go another one here. All right, now here at the top, we'll want to go ahead and factor this. All right, so this will factor to x plus 3 and x plus 2 over x plus 1, x minus 1. All right, so x-intercepts, we set the top equal to 0 and solve, which means we set each of these factors equal to 0 and solve. So we're going to get x equals -3 and x equals -2. All right, y-intercept, we plugged 0 in for all of my x's, and I end up with 6 over negative 1, which is negative 6. Vertical asymptotes, we set the denominator equal to 0 and solve. So x is going to equal positive and negative 1. Horizontal asymptotes, again, we compare the degrees of the numerator and denominator. They're the same. So we take the ratio of the leading coefficients. All right. No factors canceled out, so we don't have any holes. All right. We can get some extra points here. Again, my graph here goes from negative 10 to 10. All right. Then on either side of all of my vertical asymptotes, so here we will have negative 2 and 0 would be on either side of negative 1. However, we really don't need them. You can put them if you want, but we know that negative 2 is going to be one of my x-intercepts, and we know that 0 is my y-intercept. And then I'll need positive 2. For positive 1, we would go either side of that would be 0 and 2. 0 again is my y-intercept, so I can just use 2. So when I plug negative 10 in here, we're going to get 100 minus 50 is 50, plus 6 is 56, over 100 minus 1 is 99. All right, and you can estimate that. Obviously, points don't have to be super specific here. That's just a little bit over 1/2. If I plug 2 in, we get 4 plus 10 plus 6 is 20, over 4 minus 1 is 3. So that's going to be 6 2/3. All right, and when we plug 10 in, we get 156 over 99, so just over 1.5. All right, so we go ahead and put our asymptotes on here. We're going to get positive and negative 1. And horizontal of positive 1. All right, so now we can put our points on. All right, we have negative 3 and negative 2 of x-intercepts, y-intercept of negative 6. All right, we have negative 10 just over 1/2. We have 2, 6 2/3. And we have 10, a little over 1.5. Okay. Now, these are the only x-intercepts. Okay, you can't create new imaginary x-intercepts. So I have to go down here, and I have to go up here, and this is really it. Now, if you're confused at what you would have to do there, you can always use those one-sided limits. So the limit as x approaches negative 1 from the left, and you would find that it has to go to positive infinity. But you can also just use the fact that these are our x-intercepts, and we can't create any more, right? Like if you wanted to come back down, you would have to create a new x-intercept, which we can't do. Same thing over here. If you tried to do anything extra, you would create an extra x-intercept. Right, this piece is fairly easy here. Right, now down here we only have a few options, right? We can either kind of make it look like a cubic going one way or the other, or it can look kind of like a parabola going up or going down. Now again, we don't have any x-intercepts here, and we can't magically create extra ones. We can only use what we have here. All right, so if we use that concept, then I'm going to know that this is going to have to do this. Because if I opened up, I would create 2 new x-intercepts, or if I did like a kind of a cubic looking thing, then I would create an extra x-intercept. So this is my only option. Again, if you get stuck here, you could also just use your one-sided limits, and you would find that they would both go to negative infinity. All right, now I recommend you pausing here and go ahead and trying this one on your own. And once you do that, go ahead and unpause and try the video. You want me to close it out? You can leave it open, that's fine. All right, so getting back to our problem here, we just go through all of the same steps as normal. We are going to want to factor here. So here we'll have x minus 5 and x plus 2. Down below, we'll have x minus 3 and x plus 1. So x-intercepts, we set the top equal to 0 and solve. So we will have 5 and negative 2. Y-intercept, all right, we said plug 0 in for x. Negative 10 over negative 3 is just 10/3. Vertical asymptotes, we set the denominator equal to 0 and solve. So x is equal to 3 and negative 1. Horizontal asymptote, compare the degrees of the numerator and denominator. They are the same. So it's the ratio of the leading coefficients, which is just 1. All right, nothing canceled here, so we don't have any holes. Again, we can get our extra points from my end points of negative 10 and 10, and on either side of vertical asymptotes. So on here I would have negative 2 and 0, which of course I don't need 0, that's my y-intercept. And here I would have 2 and 4. So we plug these into our function here. We get 130, 120 up top over 120 minus 3 is 117. So just over 1. When we plug negative 2 in, we get 4. 10 minus 10 is 0. We should have known that because it's one of my x-intercepts. We plug positive 2 in. We get 4 minus 6 is negative 2, minus 10 is negative 12 up top. And 4 minus 4 is 0, minus 3 is negative 3. So that's just 4. Plug in 4. 16 minus 12 is 4. Minus 10 is negative 6. Over 16 minus 8 is 8. Minus 3 is 5. And plug in 10. And we get 100 minus 30 minus 40, so that's 60 up top. And 100 minus 20 is 80, minus 3 is 77 on bottom. Alright, so we can go ahead and put our asymptotes on here. I have a horizontal asymptote here, vertical asymptotes here, and here. Alright, now we can put all of our points on here. So x-intercept and I did obviously put this in the wrong spot. Oops. There we go. Alright, so negative 2, 5, y-intercept of 10/3, which is 3 1/3. Negative 10, just over 1. Negative 2, 0 we have. 2, 4. Whoa. This line was all kinds of whacked up. Alright, so let me say here 2, 4. Uh, 4 just over negative 1. And 10, not quite 1. Alright, so this is all pretty obvious here. Goes like this. Now remember, we can't create any new x-intercepts, so this is going to have to do this, and here, like this. And we are done. Obviously, your homework will be on Delta Math.